Today we will discuss about one problem which was appeared in CSIR NET examination. The question is as follow. The band energy of an electron in the crystal for a particular k direction has the form, this one is the form of the band energy of the electrons, where A and B both are constant and the Ka lies between from 0 to pi, and the electron has a hole-like behavior in the following range of k. So we have to find out in this energy band, if this is the band energy, so when in which range of the Ka the electrons will behave like a hole. So that means, suppose if there is a crystal and electron is moving inside this crystal. Suppose this is a crystal and electron is moving inside this crystals. So electron will feel the resistive force due to these crystals, and the mass of the electrons will modify to the effective mass of the electrons. Suppose F is the force acting on the electrons, so this will be E times electric field, because E is the charge of the electrons and negative because the electron has negative charge, and this will be equal to the effective mass of electron times A, because we can write the mass force as a mass time acceleration. Similarly, for the whole case also we can write, but in case of hole this is the positive charge, so the force will be E times small e times capital E, this is the charge and this is the electric field, and this will be hole, effective mass of hole and acceleration. And from this equation we can get that the effective mass of electron will be nothing but E times capital E divided by A, and from this expression we can get effective mass of the hole will be E times A by A. So here in the question it is given that we have to find out where in which range of the Ka the effective mass of electron will behave like a hole. That means effective mass of the electron will be exactly same equal to the effective mass of the hole. So that means you can see here there is a negative sign difference between the effective mass of the hole and effective mass of the electrons. That means we have to find out the region or the range of the K in which the effective mass of electron will be a negative quantity. But we know the effective mass can be calculated by this formula, by h square by del square E by del K square, and this is a constant, so we have to find out in which range of the Ka this del square E by del K square will be a negative quantity. So that's why we have to find out first del square E by del K square. And the energy of the energy band is given like that, A minus B cos 2K A. So if I take the first derivative, so this will be by dk, which is B 2A, so it will be sine will be minus, will be plus sine 2 cos Ka. Okay, again if you take the second derivative, then this will be B 4A square cos 2Ka. Now this is the second derivative, and effective mass is the nothing but h square divided by del square epsilon by del K square. If this is a constant, so this effective mass will be negative quantity when this is a negative quantity. That means this expression will be a negative quantity, and here B and A all are the A are the lattice constant, B is the constant, so this will be a negative quantity when this is a negative quantity. That means the cos 2A will be a negative quantity. And we know that in trigonometry that in the first quadrant all are positive, second quadrant sine positive, and third quadrant cos positive, and that is tan positive. So in this case the the cos 2a will be negative tan positive, and this is cot positive, cos positive. So here that means cos is negative in this quadrant and this quadrant. That means, so cos is negative when Ka will be from pi by 2 to 3 by 2, because cos theta is negative here and negative here. That means cos Ka will be negative from pi by 4 to 3 pi by 4. Okay, so that means this cos 2a will be negative in this range. So if this cos a is negative, that means the effective mass of the electron and the effective mass of the holes will be similar. That means electron will behave like a hole. So that means this option, first option, is the correct option.